Today we're going to discuss another theorem which is called as areas of similar triangles. And before I explain you the entire proof, let us understand what exactly the theorem has to tell us. Okay, so the theorem states that the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. So if I have this triangle which is in yellow color with blue borders, and I have a green triangle with red borders. So these are two triangles, and if I divide their areas, it will be equal to the square of those sides. So for that yellow triangle, my sides are in blue color, right? So square of one side, which is this. So if that blue line is 5 centimeter, square of that means 5 into 5 upon, if this green triangle has one of the side is red in color, which is 6 centimeters, say, so it will be 6 into 6, that is 36. Okay, so ratio of that. So the ratio of the areas of two similar triangles is equal to the square of the ratios of their corresponding sides. So whichever sides are corresponding to these two triangles, the square of that side. That's the proof. This is just a graphical representation for you to understand, and if you want to technically, how you would write it, it is that NQS represents the area of the yellow triangle, MPL represents the area of the green triangle, is equal to one line of blue color is representing QS and red line represents PL, so square of that. So this is the theorem, what exactly it is trying to tell us. So let us try now in the next section and prove this. Okay, so I have these two triangles. I've taken the same name so that you can understand it better, NQS and MPL. Okay, now for your exam, your question would be somewhat like this. Triangle NQS is similar to triangle MPL. NT is perpendicular. Perpendicular means it is going to make a 90-degree angle to QS, such that QTS, whenever they write letters like this, QTS with dashes, it just means that the T point vertex is in between Q and S, and MD is perpendicular to PL in the next triangle, such that PDL, that means D is in between P and L. Now prove that. What are we proving? We are proving that ratio of their areas is equal to square of their corresponding sides. Now you can see three different square ratios over there. It is only to tell that the triangle has three sides, right? So it can be ratio of any side that we are talking about, so square of that. So let us see how to prove it. So I've drawn the same triangles again for you. Okay, and first, so we will write, okay, area of triangle NQS is equal to half base into height. So base is QS, height is NT. So area of triangle NQS is equal to half base into height. The reason is area of triangle. Okay. In the second triangle, area of triangle MPL is equal to half base. Over here, base is PL, height is MD. Reason is again area of triangle. In the third step, what we're going to do is we will take the first and the second one and divide them. So when I divide, that half and half will get cancelled and rest everything will remain the same. Okay, now what is the reason for this? We have got this conclusion from step number 1 and 2. So I'll write that step number 1 and 2. Now we will say that these two triangles NQT, which is in green in color, and MPD, which is yellow in color, in these two triangles, Okay, this angle Q and angle P is equal. Okay, why? Because in the question we are given that triangle NQS, the entire big triangle NQS and MPL, both are similar. And if you remember, the criteria for similar triangles is that if triangles are similar, then the corresponding angles are equal. That is how we come to the conclusion that Q is equal to angle P. Now, if you have not watched that video for criteria of triangles, then I've put down the link in the description box. Watch that, because you will require, unless and until you understand the criteria, you'll not be able to solve these theorems. So coming back over here, angle Q is equal to angle P. It is also given to us that NT is perpendicular to QS. So perpendicular means it creates a 90-degree angle. MD is perpendicular to PL. So there is a 90-degree angle over here as well. So I can write NTQ is equal to MDP. The reason is it's given to us in the question. Okay. Now in this green triangle and the yellow triangle, again, criteria for similar triangles. If two angles of a triangle are equal to two angles of another triangle, AA similarity test tells us that these two triangles are similar. So based on that, I can write NTQ is similar to MDP. Okay, so the reason is AA similarity test. Now once I know that these two triangles are similar, I can write their corresponding sides, and the corresponding sides are NT upon MD, NQ upon MP. Now I have taken those sides only which I want. You don't have to write all the sides for this. So you will take the main line, which is the perpendicular line, and one of the side of the triangle. So NT upon MD and NQ upon MP. Okay, so reason is CPST. Now what is the CPST? In 9th standard you have studied something called as CPCT, and if you have forgotten about it, then please check what exactly is the meaning of that. Check what is the meaning of CPST, Google it out or find it on your textbook, it's there, and write it down in the comment section. What exactly is it? That's the homework for today. Okay, so that is the reason, CPST. Next, we can also write QS upon PL is equal to NQ upon MP. Now, how am I concluding this? This is because we are already given that NQS is similar to MPL. So, if the triangles are similar, definitely the corresponding sides are equal. That is how I come to this conclusion. Okay, now if you look in the 7th step and the 8th step, the right hand side are same, NQ upon MP, NQ upon MP, which means NT upon MD must be equal to QS upon PL. That is how I get my 9th step. So from where did I get it? I got it from 7th and the 8th step. So the reason is step number 7 and 8. Now, in the 3rd step, we are given that area of triangle NQS upon area of triangle MPL is equal to QS upon PL multiplied by NT upon MD. Now, in the 9th step, what we have said, NT upon MD is nothing but QS upon PL. So instead of writing QS upon NT upon MD, I will write QS upon PL. So QS into QS is nothing but it is QS square upon PL into PL is PL square. I have not written that step, but you know, when two sides are multiplied, there's a square coming in over there. So similarly, this is from step number 3, step number 8, and step number 9. These are the steps which are helping us to conclude this entire step. So from here, we can write similarly that if one of the side we are able to prove that it's the square of their ratios, then we can write for other sides as well. So that's the reason I've written this qs square upon pl square is equal to nq square upon mp square is equal to ns square upon ml square. Similarly, so you don't have, and you can write step number 10 over here, and that's it for this proof for areas of similar triangles. Okay, so if you like my work, please press that like button, share this video with your friends, subscribe to the channel so that you don't miss out any updates with regards to new videos coming up. And thank you very much. God bless you.